Alright, for this example here, we're going to take a look at number 6. So number 6 is talking about a 2.2 kilogram object that is whirled in a vertical circle at the time of 0.97 seconds per revolution. What is the tension on the string? So it's A and B at the top and bottom. So if we took a look at A, so an object is being swung in a circle. We know that the radius is the 1.0 meters. T, the period of rotation, is 0.97 seconds. And we know the mass is 2.2 kilograms. Those are all the numbers given to us in the question. Now, I also know the acceleration of gravity is 9.81 meters per second squared, and that is negative downwards. Now, if I've been paying attention, I should know that Fc is typically equal to Fg plus Fn, being careful of the direction. Now in this particular case, and earlier on in the notes, I mentioned that really, whether it's a hard surface that is providing the force to force something to go in a circular path, or a string that is held there, we can basically say Fn is equal to Ft in just different scenarios. So in this particular case, Fc is equal to Fg plus the tension on the string. Now Fc is not going to change, Fg is not going to change, it's basically the tension on the string that can change. So what are we going to have to solve for? Well, I'm not an expert, but I'm going to guess that to solve for the centripetal force, we're going to need a velocity. Now I know that the centripetal acceleration is equal to v squared over r, and I also know that v is equal to 2 pi r over t. I can continue on and say that the force centripetal is equal to mv squared over r. So whether I solve for velocity, then the acceleration, and then just simply slide that into an F is equal to ma, or just simply go straight to this equation here, either way I'm going to solve for Fc. Now in addition, I have a nice easy equation here of force of gravity is mass times gravity. What this will leave me with is the tension of the string at the top, if that's the one I'm doing here, or at the bottom if I do B next. So if we walk through these equations, the velocity is 2 times 3.14 times 1 meter times 0.97 seconds. We get a velocity of 6.4742. Moving straight down to the centripetal force equation, we're going to take our mass of 2.2 kilograms, multiply it by 6.4742 meters per second squared, divided by 1. This gives us a force of 92.2143. Now to solve for force gravity, that's pretty easy. 2.2 kilograms times 9.81 meters per second squared gives us a force of 21.582 newtons. Now our centripetal force can be plus or minus depending on the location in the vertical circle. Force of gravity is always going to be negative. So now if I look at my Fc with Fg plus Ft, if we were looking at the top of the loop, my Fc will be down towards center. That's downwards, so negative 92.2143 is equal to my force of gravity, which is a negative 21.582 newtons, plus my force tension. Mathematically, if I add 21.582 to both sides, I get a force tension of negative 70.63 newton, which makes sense. It should be a downward force tension, and it's a value of 70.63. Now B is actually super quick because I don't need to calculate any new numbers. Still traveling at the same speed, so the centripetal force is going to be the same. Force of gravity is still going to be the same because the mass has not changed. However, my tension will change because directions have changed. Now at the bottom of the loop, my force centripetal should be upwards, my force tension should be upwards, but my force gravity is downwards. Now my math, Fc is equal to Fg plus my force tension. I now have a positive 92.2143 newtons is equal to a negative 21.582 plus my force. So of course, same thing, I'm going to add my 21.582 to both sides. We can now see mathematically those add. So I get a positive 113.80 newtons is equal to my force tension. Now this should make sense. If we compare the two, if I'm swinging something in a loop, if I look at just the magnitude of the force, I'm going to be experiencing much less tension on that string if you were holding it than you would at the bottom. You're going to be experiencing a much greater force at the bottom. Now again, you can think of this, if I had just a bucket full of sand or water, if I was swinging it in a circle, it should be feeling more straining, more force exerting on my arm, kind of at the bottom when it's close to the ground as opposed to up in the air. Now if you don't believe me on this, come on by, I'll give you something heavy to swing. But hopefully that helps a little bit. That's question number 6. And again, I didn't do this to the correct significant digits yet, but if we take a look at the answer key, this I believe is the correct answer is 114 newtons, which is what mine would round up to at 3 significant digits. All right, good luck on the rest of the questions, and we'll catch you later.